For this last situation, it's a little bit more complicated because we have friction present and we have to be extra careful to account for friction whenever we have it in one of our problems. So once again, we are going to look at these four diagrams along the top before we look at the graphs. We have two springs, we have a ball, and we have that frictional section on the bottom. Now, friction is always going to convert some of our energy into heat. That's why when you rub your hands together, they warm up. That is energy that's being lost to the environment. You will not get that back. So we're going to ignore the graphs on the bottom, and we're going to take a look. We're going to, again, let's assume 6 blocks total. So our total for all four of these diagrams should be 6, which means that in every case, the energy that all of these objects collectively have together should total to 6. Looking at the first diagram, I have 0 blocks in spring 2 because spring 2 has not been compressed yet. I haven't even gone over the frictional section, so I'm going to say that I have lost 0 joules or 0 blocks of energy to heat. I haven't interacted with that yet, which means I have to split the 6 blocks up between the spring and the ball. I'm going to go ahead and say that the spring has 5 blocks, and we'll say that the ball has 1 block of gravitational potential energy. Again, you can play around with those numbers, but I'm going to assume the spring has 5, the ball has some height, so it has 1 block of gravitational potential energy. Looking at those four values, 5 plus 1 plus 0 plus 0, that totals up to 6, so I'm good with that diagram. Looking at the second diagram, let's start with the springs. Neither spring is compressed, so there's 0 blocks of energy in those. I just ran over friction. So what I have to do is some of that energy is going to be converted to heat or sound or something that unfortunately is not helpful to us. I'm going to assume 1 block. 1 block of energy has basically been taken away because friction removed it. Therefore, I can only potentially have 5 blocks in the ball. And in this case, since the ball is moving but it's on the ground, those 5 blocks would have to be EK. So we still have a total of 6. 5 of them are currently in the ball. 1 of them, unfortunately, friction took away, kind of converted to heat, went off into the environment to do something else. All right, now we look at diagram number 3. So the springs still have 0 because they are not compressed. We cannot ignore the fact that we lost 1 to the friction. So yes, even though we're moving down the road, we went over this friction, so we still have to account for the 1 that we lost before. So we have to account for that 1 that was lost for every single point after we've gone over friction. So I'm actually going to go ahead for diagram 4, and I'm just going to make sure I record that 1. We have to realize that once we went over friction, in every future diagram, we lost that 1. We cannot get it back. All right, in the case of diagram 3, when we jump back there, the ball is now higher than it was originally at the beginning. So first diagram, it had 1 block. It's now higher, so I have to give it at least 2. So I'm going to go ahead and give it 2 just because it's technically a little bit higher. Lost my train of thought there for a second. All right, it's higher, so it has 2 EG. All right, so it's moving, so it's got to have some kinetic. Well, if you look, 1 block was lost to friction. 2 blocks are in gravitational potential. There's none in the springs, so to get this up to a total of 6, we're going to have to assume that the kinetic is 3, because 3 kinetic, 2 gravitational potential, and 1 with the friction is going to total up to 6. Now we look at the final diagram. Spring number 1 has 0 because it has not been compressed. I lost that 1 for friction, so that's been gone. So I have 5 left to split between the ball and the spring. Now, the ball is the exact same height as it was in the previous diagram, in which I gave it 2 blocks, so I have to give it 2 blocks of EG. It's the same exact height as it was in the previous diagram. It's no longer moving, though, so we say the kinetic has to be 0. The energy that we're missing, the 3 blocks, must be in the spring. Because we've lost 1 to friction, we have 2 in EG. There's only one object. There's only one other object that can have energy, which is spring number 2. So therefore, it has to be 3, because a total of 3 plus 2 plus 0 plus 1 plus 0 for all those objects gives me 6. So now that I spent the time to do that, now the graphs become quite a bit easier. System 1, spring number 1 and the ball. So spring number 1 has 5 blocks of EEP, and just reading that off top from my first diagram. The ball has 1 block. Since it's not moving, it must be EG. It's not moving, so it has no EK. So with the 5 blocks for spring 1, the 1 block of EG for the ball, and that's all that's in this system. Now I take a look at the second diagram. I'm still only looking at spring 1 and the ball. Spring 1 has no energy. Spring 1 has no energy, so I cross that out. The ball, as you can see, we said it has 5 blocks of kinetic energy. It's on the ground, so it has no gravitational potential energy. Now I go on to diagram number 3. The ball, as you can see, has 2 blocks of EG, 3 blocks of EK, And elastic potential energy for spring 1 is still 0. Finally, I go to the last diagram. The ball has 2 blocks of EG, no EK, and spring number 1. Remember, the system is spring number 1 in the ball. Spring number 1 still has 0. Yes, spring number 2 has 3, but we are only looking at spring 1 in the ball. Now we go from left to right. Diagram 1, or graph 1 had 6 total blocks. Diagram 2 has 5 total blocks. Work must have occurred. That work was the friction that was taking that energy out of the system. Then I look at diagram or graph 2, which totals to 5. Diagram 3 or graph 3 equals 5, so there's no work between them. And then comparing 3 and 4, I go from 5 total blocks of energy to 2 total blocks of energy. That is a change, so work must have occurred. What happened? The ball lost 3 blocks of energy to spring 2. Spring 2 is not in our system, so we can't account for that. We say it's gone. It's left to something that's not part of our system. Let's look at the second example. So now we're looking at a system of the ball and spring 2. So the ball, again, up top has 1 block of EG. It's not moving, so it has no EK. And spring number 2, all the way at the end, has yet to be compressed, so it has 0 blocks of energy. In the second diagram, we see up top that the ball has 5 blocks of kinetic energy. The ball is on the ground, so it has no EG. And spring 2 has yet to be compressed, so therefore we have no energy in the elastic potential form. In the third diagram, we can see again the ball has 2 blocks of gravitational potential. It has 3 blocks of kinetic. Spring number 2 still has not been compressed, so that has 0. In the final case, the ball up top in that diagram has 2. It's not moving, it has 0. And spring number 2 now has some energy. We see that it has 3 blocks. Now we can go from left to right again. 1 total block in diagram or graph 1, 5 total blocks in graph 2. That means that work has occurred. We have 2 things going on here. Spring 1 pushed the ball forward and friction slowed it down. So there's a lot of things that are acting on this ball that are not in the system. Spring 1, the friction, so this is where this work comes from. From graph 2 to graph 3, we have a total of 5 and a total of 5, so no work has occurred. From 3 to 4, a total of 5 and a total of 5. No work has occurred there as well. Finally, we can go down to the bottom. We're only looking at spring 1 and spring 2. Spring 1 has 5 blocks. Spring 2 has 0. So that's a total of 5. And we're not considering the ball at all, so we're not going to have any gravitational or kinetic. In the second diagram, we ignore everything but those 2 springs. Those springs have no elastic potential energy, and they're not moving, and they don't have EG in our cases, so it's got to be 0. Once again, diagram 3, everything is 0, because we're not considering the ball, and those springs are not compressed. Finally, in the last case, we look at spring 1, which has 0. We look at spring 2, which has 3. That gives us a total of 3 elastic potential energy. And as we said, the springs aren't moving, and we don't assume that they have any EG. So I wrap up with 3. Looking from left to right, in the first graph I have 5 blocks. Second graph I have 0. That means work has occurred. Friction took some of that energy away, so did the ball. From 2 to 3, 0 total for 2, 0 total for 3, no work occurs. From 3 to 4, 0 total to a total of 3, that is work. The ball, which is not part of our system, gave some of its energy to spring 2. So something outside of our system gave some energy, introduced some energy, and that's where this concept of work comes from.